All right, so what we're going to do today is we're going to tackle the idea of climate change, whether it happens suddenly or if it happens slowly over the course of time. Today's learning target is going to be E5.4-B as in boy, and we're going to focus on basically three things. First of all, how do major volcanic eruptions affect the climate? Second, how do things such as moving plates, plate tectonics, cause a change in the actual possible temperatures and climates throughout the course of the history of Earth? And then third, we'll kind of talk about how those things are relevant, where we've seen them actually take place, looking at our history of Earth, and more particularly looking at the things that have happened within the last 20 plus years to give you a good example of exactly how these things can truly affect our global climates as well as our global temperatures. Okay, so let's go ahead and get started. Cools when particles block the sun. All right, so we're going to first talk about when we send things up into the air and how that can readily affect Earth. So the first thing is, what can cause temporary changes in climate around the world? All right, there are a couple things that may come to mind instantly, but most of which all center around some sort of freakish event that's created by Mother Nature that is a sudden release of usually a massive amount of particulates or small particles or small materials such as dust just being spewed up into our atmosphere. Along with that, the specific example would be volcanic eruptions. In the last 20 plus years, we've had two major eruptions on Earth that have sent incredible amounts of dust and material and gases into our atmosphere. The one here in the United States was the one that happened with Mount St. Helens in the 80s. So most of you were not born when that took place, but nonetheless, it was quite the event and had a huge impact on the global temperatures for a number of years. So when that happens, what you're doing is you're taking a huge cloud of gas and dust. So you're not just sending just dust and particulates up in there, you're actually sending gas, and most of which is carbon dioxide. And it goes up into one of the layers in our atmosphere called the stratosphere. And there are other layers as well, but the stratosphere is the one that gets, okay? And then while in the stratosphere, the global winds, because of the spinning and rotation of the Earth, those global winds cause it to be spread globally. So you don't just have to deal with the dust and particulates and the gases in a particular place in which the eruption takes place, but it's globally. And that can affect the temperatures as well as the overall climates of these places throughout the entire globe. And most of which is done because of this gas called sulfur dioxide, which is basically what can turn itself into what you may know as sulfuric rain or acid rain. Some of you might like to call it. So when this happens, the gas combines with water, okay? And when that water gets into the air, mixes with this gas, it creates this sulfuric acid. The sulfuric acid has the ability to block sunlight from actually entering into our atmosphere. So if that takes place, you are actually preventing radiation from getting into the Earth, and rather than causing Earth to actually increase in temperature, you're actually causing Earth to fill in the blank. Yeah, drop in temperature. And that decrease in the actual temperature can go on for several years. Example, when Mount Pinatubo erupted, which is in the Philippines area, you can see over the course of the time and year in which what was actually physically taking place, and that was an actual change in the actual temperatures and how they were being affected based upon the amount of dust that was in the air. And that's what this is measuring, showing exactly how much dust and how many particulates were actually in the air when this took place in 91, and then fast forwarding all the way to 93, and then even to the early phases of 94. So you're talking when Pinatubo erupted in 1991, it took over, give or take 2.5, almost 3 years, and you still had dust and particulates in the air from that particular eruption. So this is some of the dust that headed towards Hawaii. In space, what's crazy is when we had a space shuttle in there, and it was just northeast of the Hawaiian Islands. So a picture that was taken right here from the shoreline, and now a picture taken from the Earth. The blue atmosphere is due to scattering of solar rays, so we get this blue hue. The whitish gray layer is thin, and it's suspended material, so you got some dust. But here's the deal. Where you see the red bands right in this particular area here, those red bands are because of Mount Pinatubo when it erupted in 91. So that's what you see actually suspended in our air because of this scattering of dust along with the water vapor mixing with it, and then even the smoke that was given off from it as well. So kind of a cool little view to see those things actually up in the air when you're literally up in space. The second thing is the large object impacts. All right, so a lot of times, you know, Earth is hit by different things in space. Some are so small they never actually make it to Earth's ground. They burn up in our atmosphere, and a lot of you like to call them shooting stars. Well, what it is it could be something the size of a piece of sand that's literally burning up in our atmosphere due to friction, and you get this streak of light, and everybody's like, "Oh, did you see that?" And it's here and gone. It only lasts for just a few moments, a few seconds, and then it's done. Some of these objects, however, are much larger, and if they are, usually objects that are 2 miles in diameter. So we're talking, you know, 8 laps around a track, or we're talking maybe from the Hamilton Middle School down to the Mobile, I believe it would be basically 3 or 4 trips. And that happens about every million years or so based upon our history and looking at what we found on Earth. So when these large objects hit, they create a very large explosion, obviously, because they hit. They create a crater, a pit, and then as they hit an impact, when it hits, it comes into smaller materials and it breaks apart and then spews up into the atmosphere, and then that leads to how it can physically block out sunlight. So again, causing temperatures to change. The third is always an interesting one because for the most part, I think a lot of you, including a lot of scientists and just people in general, would be willing to say that the dinosaurs were became extinct because of some sort of object impacting Earth and causing the temperature globally to change and cause the climate to change, which caused them to go extinct. There is an argument out there, and it's gaining some steam, but it's still, you know, not on par with something having hit Earth, and that is what happens when the continents move. When the continents move, they actually allow gases and different items from the interior of the Earth to actually make their way into the Earth's atmosphere and basically to the surface. When that happens, they can cause a change in the climate, not only because of the shifting and moving, as you see right here. As they move farther away from the equator, it gets colder. When they get closer to the equator, it gets warmer. But there is a change in the currents. So these gases, as it opens itself up and gases from the interior of the Earth start to come up when there's opens and gases from these separation or collisions that are taking place, that can take, when you have an ocean current which is taking things away from the equator, it can also cause those gases which are rising from down below, and they're rising to the surface, and all of a sudden you add a current moving it away, it can change the actual climate because of that as well. It's spreading it out. So as they collided, they created mountain ranges, and they also changed the direction of the wind. So not only are you dealing with the potential of the gases rising in the ocean and the currents moving it, but if the gases made it out of the ocean into our atmosphere, and all of a sudden you now have mountains which are being formed because these plates are colliding with one another, those winds that are blowing take that gas and can then shoot it up into our atmosphere because of these mountains which have been created. That's different. That's a whole different thought about maybe what caused our climate change in years past before what we see now in the last 150 years. So just a brief introduction and a summary of part 1. When you're ready, go ahead and move on to part 2.